data. So one of the first ways that you can display data is with a dot plot. So here's an example, and we want to figure out which gender is taller, males or females. So here's a sample of 14-year-olds from the UK and was randomly selected. And here's some heights in centimeters for these different students, and you can see that they're broken out into males and females. So as we look at the dot plots, we could make two separate dot plots. So let's say, first of all, since the males came first, we talked about the males. And when you're doing a dot plot, you really pretty much want to have like a number line. And then along this number line, you'd want to be able to display the lowest value, probably, which would be 151. And then all the way up to the highest value, which looks like is 187. Does that look right? So 2, 3, 4, 5, 6, 7, 8, 9, 60, 1, 2, 3, 4, 5, 6, 7, 8, 9, 71, 3, 4, 5, 6, 7, 8, 9, 10. So 51, 52, 53, 4, 5, 6, 7, 8, 9, 160, 1, 2, 3, 4, 5, 6, 7, 8, 9, 170, 1, 2, 3, 4, 5, 6, 7, 8, 9, 180, 1, 2, 3, 4, 5, 6, 7. And then basically all you do is you put dots and go vertical from that point. So for example, 154 would be 1, 2, 3, 4. So here's 154, 175, 187, 163, 167, 159, 169, 162, 176, 177, 151, 175. And what you can see is as you place your dots there, you're going to go vertical from what was before. So if you have more than one dot, you're going up vertically. And here would be the dot plot for the males. So we could do this same exact thing for the females, of course. And looking at their smallest score, I see a 152. And it looks like the highest for them is 169. 2, 3, 4, 5, 6, 7, 8, 9, 160. 1, 2, 3, 4, 5, 6, 7, 8, 9, 170. And then just do the dot plot for them as well. as you can kind of see with the females at least, it looks like their heights are a lot more dense than the males are. The males are much more spread out. Okay, the next kind of display that we're going to talk about is a stem plot. So I'm gonna do one stem plot first, and I'm going to show you something called a split stem, where you can display two sets of data at the same time, which is kind of nice. So if you don't remember, maybe back in Algebra 2 you guys call this stem and leaf. So they abbreviate with stem. So in a stem plot, if I was going to do the males, for example, I would do stuff like this. If you look in the male table that they gave, or the set of data, you'll notice that the shortest heights begin in the 150s. So I might go with 15 to represent 150. And then as I go across, I notice that there is a height of 151 and 154. I could also do, if I wanted to, splitting it up, I could actually write down the rest of the 150s. So I could do 7 and 9, because there's 157, 159. For the 160s, I have 162, 163, two 165s, a 167, and a 169.
You're doing males or females?
Males.
Males are 365s.
There's 3?
Yep.
Oh, my bad, sorry. Did I miss one? Doesn't exist? Oh. Alright, well then, Bart's keys one. That's right. Is there or not? 157. Is there a 157? No? Okay, sorry, my bad. 159. There's a 9, right?
Yes.
Okay, good. Let me know if there's any other errors. For the 170s, 174, 175, 176, and 177. 275s. And then for the 180s, 180, 183, 187. Yep. Does that look right? So if I want to do a split stem, I can put a label over the top and go like males over here. And then to do the females, I can just come off the other side, label with an F, and then start writing down the females. Like for example, 152, 153, looks like there might be a couple of those. 157, 58, a couple times, 3 times. And a 159. And then for the 160s, there's a couple of those. A 161, a couple of 163s, bless you, 164, a couple of 165s, a couple of 166s, 167, 168, and a couple of 169s. Okay, so this would be one way to display the data. You can definitely see here the big difference if you wanted. The other thing that you could do, if you wanted to, is you could actually split this stem and leaf into a couple of 150s. So for example here, I put all the 150s on one line. All right? But what I could have done is I could have put the 150s, 151, 152, 153, 154s on the first line, then made a second 150 line, and gone 156, 157, 155, sorry, 156, 7, 8, and 9. And generally, whenever you're doing things, statisticians like to have somewhere between 5 to 10 lines. Okay, and so here we have 4, so this is kind of short. So oftentimes what they'll do is they'll split each stem into 2 pieces to see a better distribution. It's kind of like with histograms. So if you were going to write that, what you would have done instead, so I'm going to erase this now and I'll show you what it would have looked like. And you don't have to write this down, but I'll show you what it would look like if I would have split it up in a split stem with 2 150s. So it's already been displayed. It'll be on the video. And here's what it would look like if I redid it. And there might be some errors in the numbers I'm writing down, but you'll get the idea of what it looks like. So for the males, if I'm doing the 150s, instead of having just 150, I'd go 150, 150, 160, 160, 170, 170, 180, 180. Here would be my males. So for the 150s, I'd have 1 and 4. And again, some of these numbers might be wrong, but you just bear with me and you'll kind of get the idea of what's going on. And then for the females, coming off the other side, kind of the nice thing is like the male data was not so bad when we had the 4 lines, but the female was kind of scrunched up. Oops. So this kind of displays a little bit more spread out to get a better idea maybe of what's going on. And here you see how dense, again, the females are in that 150 and 160 range, whereas the males are much more spread out, and you can kind of see kind of a curve. We're going to talk a lot about distributions. You can kind of see the distribution here. It looks kind of like this. And if you were to turn it on its side, it kind of look like a mountain. And algebra 2. So if I'm looking at histograms, let's just talk about